Okay, welcome back. We're going to continue our look at these special functions. And today we're going to concentrate on the derivative of the natural logarithm. So when you're taking the derivative of ln u, it has two parts. The first part is 1 over u. So u is the argument of the logarithm, and that's how you begin. You take 1 over u, and then you multiply that by the derivative of u itself with respect to that independent variable, usually x. Okay, so two parts, 1 over u, and then you multiply that by the derivative of u. So I'm going to go through and solve 7 examples with you. Okay, so here's the first example. We have the ln of x to the power of 4. Okay, just give me 1 second. I'm going to get another colored pen. Okay, so the first thing to note is that the exponent here of 4 is only on the x. Okay, so this means that right now we have this. We have the ln of little u. Okay, so in forming the derivative, again, there are going to be two parts. And the first part is 1 over that little u. And then we have to multiply that by the derivative of the little u. So what is the derivative of x to the power of 4? It's 4x cubed. And then we're all set. We're going to simplify. So again, 1 over u times the derivative of u. So this then becomes 4x cubed over x to the power of 4, and this reduces to give us 4 over x. And 4 over x then would be our final result here. Okay, so again, two parts, 1 over little u, and then multiply by the derivative of little u. Let's take a look at this next one now. We have x cubed multiplied by the ln of the sine of 5x. Now, we definitely have this variable in two different places, and there's definitely multiplication involved here. Right here is where we have the product of two functions. So it's as though in the front here, we have one function u. I'm going to try to use like an uppercase u. See, my lowercase ones have a little tail on them. Okay, so that's uppercase u. And then I'm going to call this the ln of the sine of 5x as my uppercase v. So we have to use a product rule because, again, the variable x is in two different places. And here there isn't addition or subtraction, but rather multiplication. So this is a product rule. So what we have to do is correctly form the derivatives of u and v. So I will do that over here. So for the derivative of u, we just need the derivative of x cubed. So that's fairly straightforward. That's just 3x squared. Now we have to figure out the derivative of v. What is the derivative of the ln of the sine of 5x? Well, hopefully you realize that this has to be considered to be a ln of a little u. So this part here now is the little u of ln u. And so that means its derivative has two parts. First, 1 over the little u. And then multiplication by the derivative of little u. So now we need to know what is the derivative of sine 5x. So you can look at your sheet. The derivative of sine 5x is cos 5x times 5, because 5 is the derivative of 5x. So again, cos 5x times 5, or 5 cos 5x. Okay, so once again, two parts. One part right here corresponds to 1 over little u. And this part right here corresponds to the derivative of little u with respect to x. And those two things are multiplied together. 1 over u times the derivative of little u. And again, little u is the sine of 5x because we had a ln u function. Okay, so we're going to use the product rule now. We could actually simplify this though. This is 5 cos 5x divided by sine 5x. And so what you get here is actually cosine over sine. And what is cosine over sine? Well, sine over cosine is tangent. And what we have is the reciprocal of this. We have cosine over sine. So what we have is the reciprocal of tangent. And the reciprocal of tangent is cotangent. So v prime is actually 5 times the cotangent of 5x. So now we have a u prime and we have a v prime, and we can use our product rule to find y prime. Okay, so there's a lot going on in this example for sure. First, we have to consider this overall to be a product rule, and then forming v prime was challenging. We had to consider the function overall to be a natural logarithm, and therefore the derivative had two parts, 1 over u times the derivative of u. Lastly, cosine over sine will always be cotangent. Okay, product rule now. And again, if you forget the product rule, you'll find that at the bottom of the formula sheet. So it's u times v prime plus v times u prime. Just like that. Okay, so this is just the same as having 5x cubed in front of that cotangent function, and 3x squared in front of this logarithm. And the only thing we can do here to simplify is maybe remove x squared from each of these terms. So we common factor x squared. So that means dividing here 5x cubed by x squared to get 5x. And here dividing 3x squared by x squared to get 3. And now we're done. Now the question is perfect and we're all set. Okay, so overall, question 2 was considered a product. And in forming the derivative of v, we had to consider this function to be a natural logarithm. This was like a composition of functions. The sine of 5x was the argument of the logarithm. Okay, let's take a look at this next example. Please note that you can't just open up this bracket. This is not the same as the ln of secant x plus the ln of tangent x. You can't do that. So all you can do is consider this to be the little u in ln u. Okay, so all we have to do is correctly use this formula. We're going to have 1 over u times the derivative of u. So, in forming y prime, we start with 1 over u, like that. So that's the 1 over u part. And now we're supposed to multiply that by the derivative of u. So we need to know, what is the derivative of secant x plus tangent x? When the function is a sum like this, the derivative will also be a sum. So basically, we're going to need a bracket again because this is a binomial. And in the bracket, we're going to write the derivative of secant x first. And then to that, we add the derivative of tangent x. So that's what's going to go inside the bracket. Okay, so the derivative of secant x, you can use your sheet, will be secant x tangent x times 1, since the derivative of x is 1. So it's just secant x tangent x. Okay, plus, and now we need the derivative of tangent x to be written here. Use the sheet again. The derivative of tangent x is secant squared x times 1. So just secant squared x. Okay, so here we go again. The first part there is the 1 over u part. And this part here corresponds to the derivative of u with respect to x. Okay, and again, this first part here is the 1 over u part. So I'm just marking this up a bit in case that helps you. So the 1 over u part is here, and that is multiplied by the derivative of u. Okay, so now we're going to simplify this a bit. We can just slide this whole thing into the numerator, and this will be the denominator. So it's secant x tangent x plus secant squared x over secant x plus tangent x, right? It means the same thing because we can take this and multiply it by the 1. So that's now the numerator. In the numerator, I can common factor secant x from both terms. So the terms are separated by the plus sign. There's a secant x to the left and to the right. So I should common factor secant x from both terms. What will that leave me from the first term? Tangent x. Then will be the plus sign. And when I divide the second term by secant x, it will leave me with a secant x. So that's the new numerator. Denominator is the same. Okay, make sure I didn't cut the page off there. All right, so see what we did in the numerator? I just common factored secant x out of both terms. You could check this, right? In your mind, use multiplication to open that up, and you should get this back. All right, so now look, this sum is the same as this sum. So those two sums can cancel out completely, and all we're left with then in our answer is secant x. So it simplifies very nicely, that one. So again, overall, this was just a logarithm. We had the ln of u, so we started with 1 over u. We multiplied that by the derivative of u. After that, we just simplified. Okay, let's try this one. We've got the cosine of the ln of 5x. And even if this bracket wasn't here, we would do this question in the very same way. Okay, so you would start by saying It's certainly not a product because there is no x here, you see? It's not like cosine 3x multiplied by ln of 5x, in which case you'd need a product rule. So there is only the one variable x. So this overall needs to be considered like this. We have cosine of little u overall. And therefore, in forming the derivative, we will use this. What's the derivative of cosine little u? It's negative sine of little u multiplied by the derivative of little u. So y prime is, so again, first, negative sine of little u. That's the first part. Okay, so this is the part, if you like having something written underneath, that's the negative sine of little u part. And now we also need to multiply that by du by dx. So what's the derivative of little u, in other words, with respect to x? That will go here. Well, its derivative is found by using the formula sheet. What's the derivative of ln 5x? Ln 5x has a derivative equal to 1 over 5x times 5. So if we have ln 5x, its derivative is 1 over 5x times 5. So that's what would go here. 1 over 5x times 5. So this is now the full derivative. We have negative sine of ln 5x times 1 over 5x times 5. Okay, so let's simplify that. What can we do to simplify that? 1 over 5x times 5 is the same as 5 over 5x, which means it's 1 over x right here. This is just 1 over x. Okay, again, that's because it's the same as 5 over 5x. If you're confused by that, this is like 5 over 1, right? So we have 1 over 5x times 5 over 1. So that's why it's 5 over 5x. So 1 over x. And we could leave it like that. And the other way to write it would be just to take that x and put it underneath as the denominator there. Okay? Some people would take the 1 over x and write it in front here instead. So you could have this negative 1 over x times the sine of the ln of 5x. Okay, so this is perfectly good for a final answer, as is this one. So this is another one of those composition of functions. One function is nesting inside of the other. And to form the derivative correctly, we had to first make sure we consider this as cos u. And therefore, the derivative had two parts, negative sine of u, and then multiply by the derivative of little u. And the derivative of little u meant the derivative of ln 5x. Okay, let's continue with some further examples. We'll try this one now. Okay, look, the exponent here means this. The whole ln function is cubed. And therefore, you might remember this is going to require us to use the chain rule in order to differentiate this. And in using the chain rule, we begin with this outside exponent here. So in forming y prime, the first thing that happens is the 3 comes forward. And the new exponent is decreased to 2. So this happens when you begin the chain rule. Inside of the bracket stays the same. And now, of course, we have to multiply that by the derivative of the inside of the bracket. So the derivative of ln of sine 3x goes here now. Okay, so you do the exponent bit and then you multiply by the derivative of the inside of the bracket. So how are we going to form the derivative of the ln of the sine of 3x? Well, we have to consider it to be a ln of little u. And so it's going to have 2 parts, remember? 1 over little u times the derivative of little u. So 1 over little u corresponds to 1 over sine 3x. And that is multiplied by the derivative of little u. So right here, we need the derivative of sine 3x. And from your sheet, that is cos 3x times 3. Or 3 cos 3x. Oops. Not sure what the deal is with the bracket. Don't need that. Okay, so let me go, oopsie. Let me go through this again. So after you do the exponent part and you're trying to multiply by the derivative of the inside of the bracket, we need the derivative of ln u. So this is 1 over u multiplied by the derivative of u. Okay, so again, if you like to mark it up, you can say this is the 1 over u part. And right here is the derivative of u part, like that. Okay, and together, that product is now the derivative of the inside of the bracket. Okay, so we're going to simplify this. So we can leave this part alone if we want. Let's simplify this part. It's 3 cos 3x over sine 3x. All right, that can be written like that. And then maybe you remember, what is cosine over sine? That's cotangent, right? So cotangent is the reciprocal of tangent, and therefore it's equal to cosine over sine. And I mean, you might want to even add that to your formula sheet. You can write cosine theta over sine theta here, if you want to have that written down. Okay, so then this becomes 3 times the ln of the sine of 3x all squared times 3 cotangent 3x. And we wouldn't leave it like this. We would change that to a 9 out front. So 9 is out front. And then you could either have the ln function next or the cotangent function. That's up to you. Okay, and then you can finish with this bracket with the square, or you could even put the square back here so that it resembles more the original presentation. So that's up to you. You could have left this exactly here instead. Okay, so that is question 5, which needed the chain rule. Let's look at this one, number 6. Function of x in the top, function of x in the bottom. So this is going to be a quotient. So I'm gonna call that an uppercase U and an uppercase V, and we're gonna use the quotient rule, which means first I'm gonna write out what is U prime and what is V prime. So U prime is the derivative of the ln of x squared. Now, this square is only on the x, okay? So remember, this means something entirely different. This square here is only on the x. And what does that mean? That means this is like the little u in ln u. So what's the derivative of ln x squared then? Remember, it has two parts. 1 over little u times the derivative of little u. The derivative of x squared is 2x. So this is the same as 2x over x squared. And that is the same as 2 over x. So 2 over x is what we're going to use for u prime. Now, let's do v prime. V is the cos 3x, so 3x is the little u in cos u. What's the derivative of cos u? Negative sine u times du by dx. So in this case, we have cos 3x, so it's negative sine 3x times 3. Or negative 3 sine 3x. Just like that. So now we have u prime and we have v prime, and we're going to be forming y prime using the quotient rule. It's on your page, okay? And it goes like this. V is multiplied by u prime. From that we subtract u after multiplying it by v prime. And that whole thing is then divided by v squared. Okay, v times u prime minus u times v prime over v squared, just like that. Okay, now the dangerous thing is that you are maybe tempted to take this 2 over x and multiply it by this 3x. That is not possible. And if we were in a classroom, I would ask you to tell me why that isn't possible. Okay, and the reason is the 3x is the angle. It's the argument of the function, and that should not change. Okay, so do not ever touch those angles. Even back here, right? We had this 1 over x. You never multiply it in here because the argument should stay 5x the whole way. And same thing here, right? Don't take this and multiply it by the 5x because the 5x is the argument of sine. It's the angle, so don't change that. Okay, so we can just maybe move this to the front. So we have 2 over x in front of the cosine of 3x. Now look, this term is all one term. So we have a negative 1 multiplied by a 3. So this is plus 3. And now I could either write the sine term or the logarithm. The order doesn't matter. So I'm going to write plus 3 sine 3x times the ln of x squared. So that's the numerator. And underneath is still this, which we could keep writing it the same way, or you could squeeze it to cos squared 3x. Okay? So I took that term, wrote it here. This term is now plus 3, and still has the sine and the logarithm like that. Last thing is, in this example, it's a little awkward to have a fraction in the numerator of your fraction. And no, you can't just drop this x down here. The way to handle this correctly, since we have a binomial on top, is to multiply all three terms by x. So then it becomes 2 cos 3x plus 3x in front of this term and an x in front of this term. Okay, and now you no longer have the awkwardness of having a fraction in your fraction. Okay, so all I did was I multiplied this term by x, this term by x, and this term by x. Okay, so here multiplying by x gave us 2. Here we multiplied by x, and in front here as well. Okay, why don't we do one last problem together? This video is gonna get too long otherwise. I don't want to completely, yeah. Okay, let's just do this last one. So, now what is raised to the power of 4? So again, the exponent is not here, which would mean the entire logarithm was raised to the power of 4. The exponent is here, which means 5x plus 1 is raised to the power of 4. So what do we have? We have a ln of u function. Okay, so that dictates how we will be forming our derivative. Okay, so if we have a ln of u function, we know the derivative has 2 parts. The first part is 1 over u. So that's the 1 over u part. And then I'm supposed to multiply that by the derivative of the function u. So right here, we need the derivative of 5x plus 1 to the power of 4. Well, how do you form its derivative? Well, in fact, it requires the chain rule. Okay, so this is a chain rule on an algebraic function. You would have learned this in the first unit of the course. So how does the chain rule work here? Well, start with the exponent. The new exponent will be 3. And then simply remember to multiply that by the derivative of the inside of the bracket. And what's the derivative of 5x plus 1? It's 5. Okay, so all of this is the chain rule. And we used it to form the derivative of u with respect to x. In other words, for the derivative of 5x plus 1 to the 4. You just do the exponent part first and then multiply by the derivative of the inside of the bracket. Okay, so again, this first part right here, this was the 1 over u part. Okay, so it's 1 over u times the derivative of u. In forming the derivative of u, we had to use the chain rule. And now we can simplify this. This, of course, is the same as 20 times 5x plus 1 all cubed. So what we have is 20 times 5x plus 1 all cubed over 5x plus 1 to the power of 4. Oops, I'm just moving everything around. Okay, so what does this mean? It means certainly that we can reduce this by canceling 5x plus 1 all cubed. from both the top and the bottom to give us our final answer, 20 over 5x plus 1 to the 1. Like that. Okay, and of course if you want to keep a bracket around there, that's okay, but it's not needed when the exponent is just 1. Okay, so I think perhaps I should stop there. I've gone through 7 examples. I would strongly recommend that you practice some of the suggested problems on your own. Please let me know if you have questions, okay? Feel free to email me with any of your questions, and I'd be happy to respond by email or even through a Microsoft Teams meeting. Okay, have a great day. Bye.